Hello everybody. This is our next webinar about object-oriented programming. I hope you can see me and you can hear me. And this is the webinar 49. That's how many webinars we've done so far. And today I will try to explain you what cohesion is. This is quite interesting subject for me, and I'm trying to do some research in this area. That's why I decided to share some information with you. Probably you will be interested in it. I actually wrote a blog post, I think just about a month ago or so, where I explained what cohesion is and why it's important for object-oriented practitioners and scientists, researchers. I think that it's possible to use, it will be possible, it is already possible to use cohesion as an instrument to prove scientifically some of the object-oriented concepts, some of the ideas which we were discussing over the last maybe 5 or 4 years in my blog, in some webinars, in the book, and in conferences. And now maybe it's time to make the next step and to actually try to prove something more or less scientifically. And I will explain you today what I mean by scientifically proving something. But first of all, I will explain you what cohesion is, and then we will see what we can do with it. So cohesion, it is a metric. It's not actually a metric, it's a concept. It's not a metric, it's a concept, it's an idea that it's the quality. It's a quality of objects. So an object can be cohesive, or it can be less cohesive, more cohesive, less cohesive. The person who introduced that was, I think, 40 years ago in 1978. The idea was that we may somehow tell by looking at the object whether its design is, well, cohesive enough, which means that its design, the object is designed as a solid piece of functionality, a solid piece of elements. So when everything that belongs to the object stays together and needs to stay there, and it makes sense to keep everything in one piece, in one object, then we can say that the object is cohesive. When the object has too many elements, and these elements are not connected to each other, then we can say that the object is not cohesive enough. Basically, there were two qualities introduced at that time: coupling and cohesion. Coupling was meant to say that a number of objects, that some amount of objects are connected to each other. If the coupling is tight, then it means that objects are too much connected to each other. And the idea was that it's not so good. When the coupling is too tight, then something is wrong, then the objects are connected too much, meaning that objects know about each other too much. That was meant by coupling. So, for example, I am coupled to another object. If my object is coupled to another object, if I know, for example, something about the internal structure of another object. So let's say I can get access to private attributes of another object. That means that I'm coupled too much with that object. If I can get access, for example, to private attributes of another object, then I'm coupled too much. Or if, for example, if I use private methods of an object, then I'm coupled too much. Or maybe if I use, for example, without the interface, I just use directly the methods of an object instead of using them through the interface, then it means that I'm coupled too much because I depend on the implementation instead of the interface, and so on. That was coupling. And also the second idea introduced was cohesion, which was about the internal structure of the object. So if the object is cohesive, it means that everything that stays inside the object has to be there, has to stay there. And that was just the concept. And then after that, many researchers, actually scientists, started to suggest metrics, exactly the formulas to explain, to present the cohesion. Because one thing is idea, that yes, the object has to be cohesive, but another thing is specifically what you mean by that and how can you measure it. So let's say my object is cohesive. How cohesive? and this object is not cohesive. How not cohesive? So how to measure that? So the metrics, the exact formulas were introduced, and there are many of them, many different formulas. I know at least 30 of them, 30 different formulas to calculate the cohesiveness, the cohesion of an object. And today I will show you just one formula to explain you what it is and how it works. So let's take a look at the example. So this is the class. This is the class which, the class book, which has an attribute. Here it's a private attribute and 3 methods. The ID of the book, and then the method rename, the method string, and the method order. So let's say this one renames the book, gives a new name, this one returns the title, and this one says, okay, order the book, this amount of books, and send them to this address. And now this is the formula, which is, the metric is called CAMC. I don't know how it's, I can find out, but it's not important. So the name of the metric is CAMC, one of the metrics. There are many of them. There are, like I said, 30 of those metrics. And this one says, this is the formula. So CAMC of this, of an object is 1 divided by LK, and then the summary of PI. So let me explain what it is. First of all, we calculate, we put all the types which are arguments of all the methods in the object. This is the array of all types. Everything we've seen. Integer, here, string, here, and here. Return types are also types. So string here, and address over here. So in total, we have all the types. There's 3 types which we've seen in all the methods. Then the L is actually the total amount of types, 3. And K is the total amount of methods. So L is 3, K is 3, so 1 divided by 9. L multiplied by K. And then we summarize all the PI. The P is the amount of types used in each method. So how many types are used in the method number 1? It's string and void. Well, actually, this is wrong. This is not, shouldn't be 2. It should be 1. So there's 1 type, string, here. P2 is also 1, here. And P3 is 3, is actually 2. So we have integer and address. So P1 is 1, P2 is 1, and P3 is 2. And now we summarize them. 1 plus 1 plus 2. It's going to be 4. So the CAMC is 4 divided by 9. This is the cohesion of this class. Simple as that. This is one of the metrics. And of course, this metric has a scientific paper, academic paper, which explains why this is the formula, why we need to use it, why it makes sense, and so on and so on. And all the different metrics, they have their own explanation that their formula actually makes sense. So if, for example, so let's see what happens with the class. So here is 4 divided by 9. So let's say we change the class. Let's say we think that the cohesion is not good enough. 4 divided by, let's remember it. So now it's 4 by 9, okay? This is what we have now. So let's say we want to improve the class, to make cohesion higher. What do we do? For example, we can get rid of this method. We can remove the method like this. And then we have a different, calculation, a different formula. First of all, the list of types will be just 1 type, just string, right? Then the total amount of types will be 1. The total amount of methods will be 2, right? Rename and title. And then P1 will be 1, P2 will be 1, and P3 will not exist, like this. So now we calculate 1 divided by 2 multiplied by 2. So the cohesion will be 2 by 2. 1. So it's higher. The cohesion is the maximum, actually. It's going to be 1, which is the maximum cohesion which we can ever imagine. So as you can see, this metric doesn't take into account anything about the attribute. So, for example, there's only 1 attribute, but we can have like multiple attributes here, and the cohesion will be still the same. Which I think is not right, because cohesion definitely must pay attention to the attributes, pay attention to what's inside the object. It's not only methods, there are also attributes, the data, well, objects encapsulated. And this particular metric doesn't pay attention to attributes. There are other metrics which pay attention to attributes. There are metrics which pay attention to attributes and methods. Some of them pay attention only, I'm not sure I know specifically, but probably there could be metrics which pay attention only to attributes. There could be metrics which pay attention to the body of the method, because now you see we don't pay attention to what's inside the method. We don't see anything, we don't say anything about the body of the method, about the code which is inside the method, and so on and so on. So this metric is quite primitive, quite simple. It was probably one of the first which were introduced. And there are many of them, many of those metrics. So what it gives us, why do we care? Why do we want to know about this metric? What it gives us? I think it gives us not this specific metric, but in general, cohesion metrics which calculate cohesion. If we put them together, if we just use one metric, then like you see, this metric is quite silly because it's quite primitive. It only, it can be applied to the interface, even to the interface. You don't need a class for this. You can use the interface and the metric will still work. But there are many other metrics. If we put all of them or many of them in a combination, if we integrate them together in a set of metrics, then we can give this collection of metrics, we can give this collection of metrics our object, our class. And they all together will tell us something about the object. They will tell us that from different points of view, the cohesion approximately on the average is low, or is high, or is very high, or is very low, and so on. And then by using this set of metrics, let's say we put like, 10 metrics together, and then we make up a group metric, which is going to be something like an overall cohesion, which is a combination of other metrics. Then we can apply this metric to many classes. Let's take 1,000 classes or 100,000 classes. And we're going to get a huge amount of numbers. Some classes are highly cohesive, some are low, some are very low, some are very high. And then we put all this data together, like the data set, and then we look at these objects from a different perspective, from object-oriented perspective. For example, we look at them and say, which objects use, annotations. Let's say they're Java classes, and we say which of them use annotations. And then we can say that, for example, those who use annotations could be more cohesive than those who don't use annotations. And if we take a large amount of classes, not 1,000, but maybe 1,000,000 of them, and if we get the statistically, and the statistic will prove, we will statistically, empirically prove that actually classes with annotations are less cohesive than classes without annotations. And that could be some sort of a proof. I don't know how scientific it is or not, but it seems to me that if we have 1,000,000 classes and the numbers actually prove it, then that could be an argument that annotations is a bad idea, for example. And I did this experiment a few years ago, actually, not yesterday. I did this, I think, 2 years ago. I designed, not only me, but there were other people helping me. We designed this system called jpeak.org. This system is a software, and it's a hosted software. It's a software which you can use, and it's also a website where we actually do this. We put together a number of metrics, and then using this software, I did the experiment. So I found a few, not 100,000, but about 80,000 Java classes of an average size. And then I applied this metric, this combination of metrics to these classes, and I got some statistics. And I got this information. Let's take a look at the graphs. I hope you see the graphs. Let me check if you do see them. No, you don't see it. So there it is. So there are two groups of classes. The first one is here. The second one is here. So the first group of classes, about something like 40,000 classes, they are mutable. You know what mutable is, right? So it's the class which has at least one non-final attribute. So that I call the mutable class. And these are the classes which are immutable. They have no non-final attributes. And then I ran the JPEG software with a collection of metrics, and they gave me some information. And what's interesting, that the average cohesion of immutable classes is a little bit higher. It's 0.34 than the cohesion of mutable classes, 0.31. Of course, the difference is not that large. It's not very impressive. I honestly give you the numbers I got from there. And the difference is not very impressive, but it exists. So the difference exists, and I think that if I use more classes, if I use more objects, then probably, I think so, that's my prediction, that I can get even better difference, even larger difference, even better numbers. And what's interesting to see here is what's happening on the horizontal axis. Horizontally, I put the size of a class. By the size of a class, I calculate just a total number of all the methods plus all the attributes. So if you see what's going on here, then you can see that most classes are in size of probably 10, maybe 20, something like this. So they are concentrated here. And there are actually mutable classes which are like 50, the size is 50 or 60 or 70 or even 100. 100 means a class with so many methods and so many attributes that together there's 100 of them. So you can imagine how ugly is that class with 100 methods and attributes. And of course, they are mostly, these large classes are in the first graph. They're mutable. And if you look at the second graph, then immutable classes are seriously smaller, significantly smaller. Here, the average size is 47, and here the average size is 23. So that kind of proves something, right? So on a large amount of classes, we have the cohesion lower for mutable classes, and we have the size much smaller for immutable classes. So the size is not about cohesion, actually. Size is the metric which was a side effect of this research, but the cohesion is the cohesion. So the cohesion was definitely lower for mutable classes. And now my point is that we can, I think so, that's my prediction, is that we can apply the same mechanism, the same way of proving something, using this JPEG software and using the idea of cohesion. So if we take a large amount of classes, really large, like 100,000, maybe 1 million, because I wasn't able to take 1 million because it takes time to calculate cohesion, and to calculate this statistic, it took me like probably 2 days or something to work with 100,000 classes. If I take 1 million, then it will take me a month or so, which is I just didn't have time, didn't have resources for that. But if we use larger amount of classes and we use more metrics, because during this research I was using just 5 metrics, not all of them, not 30 of course, not even 10, but just 5 metrics. So if we use more metrics and if we use more classes, then we can prove many interesting ideas. For example, we can prove that static methods is actually causing low cohesion. That when our classes, they have static methods, then cohesion goes down, for example. Or when our classes, they have null references, for example. Because so many people still say that null is okay for some cases, that null is okay for some design, and null is a good thing sometimes, or maybe always. And we can prove to them, scientifically, that, that classes, when you use null, your classes become less cohesive. So that I think could be a good instrument for the future. I'm going to do this research more and more and actually publish the results. So that could be some academic work which will be published sooner or later, and I'm working on that. So my point of this webinar is that you may be also interested to join us in the JPIC project. So again, it's called JPIC. JPIC.org. So you may be interested to join us and help us to do the research. We are interested to, it's an open source product, of course, and we are interested in more metrics and more research directions. You have the data, you have the numbers, and then you analyze from different angles which classes are less cohesive, which classes are more cohesive, and then we just go ahead and prove what we are thinking about object-oriented programming, that certain things, like I described in the Elegant Objects book, that certain things are actually damaging our design and making our design worse instead of making it better. So that's basically what I wanted to say to you today. So if you have questions, you can ask, and I will be glad to answer if you have questions. I didn't want to, overload you with too complex formulas and explain all the metrics. It's not so important. The important idea is that you understand now that cohesion may be something. Yeah, there's one comment is that this is what we deserve. It's a right way of OOP design. It's engineering. Yeah, I think this is now we're getting more. I feel so that we're getting more serious with our ideas about object-oriented design. We can actually start proving something. We have all the instruments in our hands right now. We have the tool. We have the enough ideas to prove. So then now we can put it together. We have the idea that something is not what we like, and we have the tool to prove it. Then we put it together, we get the numbers, we write an article, we publish it, and see what people say. And then if we publish enough of those research papers, if we publish enough of those statistics, then probably people will start actually taking us more serious. Yeah, that's right. That's a good comment again about the calculating the design. So I think this cohesion matrix is a good way to actually put some numbers on your design. So it's not anymore about just looking at the code and judging the code whether it works or not, but also judging the design by the numbers, by the metrics, and telling whether the design is actually a good design or the design is bad. And the biggest problem for me always when I try to prove something about elegant objects and something about my ideas about OOP, it's always a question, it's always a counter argument that maybe it's just your idea. Maybe it's like it's your opinion. You think so, okay, it works for you, but it doesn't work for us. So it doesn't mean that what you say actually is right. No, it's just your opinion. Goodbye. So people don't take elegant objects seriously. They think it's just opinionated, very specific, subjective point of view to the design of object-oriented software. But if we look at this from this more statistical approach, more scientific, then we can actually say, no, it's not just an opinion. Actually, what we're saying is actually right, and it's proven that it's right. So let's say, for example, for immutable classes, people say, no, my objects don't need to be immutable. It's only you thinking that it's better to have an immutable object. And I can say that, no, it's not only me thinking, it's something which I proved. And if you look at the statistics, you will see that if you design your classes immutable, if you make your objects immutable, then the overall your design will be more cohesive, and everybody knows that higher cohesion means better software. So higher cohesion, I didn't say that, but that's like a proven, it's not a fact, but it's a proven idea that if your classes are more cohesive, then the overall, your software will be more maintainable. Everything will be better if your classes are more cohesive in object-oriented programming. So we know this for a fact. And now we say that in order to achieve that, in order to make your objects more cohesive, how do you do that? You make them immutable. You don't use static methods. You don't use null. You do this and this and this. And that's how you make your code better. So that's probably it. I'm not going to take any more of your time. I said what I wanted to say. If you're interested, you should definitely join jpeak.org. Find us on GitHub, and it's a Java project, not large. It's quite compact, so you can come up with a pull request, and you can help us to. If you want to take part of the scientific part of this project and help me write those articles and do this research, then definitely you find me in Telegram and you email me, and then we talk and discuss how you can help me do the research, and then we together can get published. So then we can together publish our numbers, our findings in conferences, write some journal articles, and so on and so on. So we are actively looking for Java developers and people from the academic side who can do the data analysis and then write some papers to present the results to the scientific community. So that's it. Thanks for coming. See you next time. Next month, I will announce the next webinar soon in my Twitter and everywhere. Thanks for coming. Bye-bye. See you next time.